Thank you so much. It's nice to be here again. So today I would like to talk about the structural design practices in the Philippines, looking back and looking beyond. So the outline of my presentations is I'm going to start now in the 1960s during the Marcos regime. And then what happened now during the August 21 when Ninoy Aquino was assassinated. And these are actually have a direct effect now on the construction business in the Philippines. Then after which, I'll talk about the EDSA revolutions, which actually started now the construction booms in the Philippines. And then the key projects now after the EDSA revolutions. And then the construction boom now starting from 1990 to 1997, before we were hit by the 1997 Asian crisis. And then after the Asian crisis, construction business was again very, very active from 2000 until today. And then I just have to tell you something about what we're actually looking forward in the Philippines in terms of the construction industry. So to start with now, in the 1968, we had this 7.3 magnitude of earthquake that actually hit now Metro Manila. It caused now the collapse of the Ruby Tower, a 6-story condominium building in the Chinatown. And actually it started now for a clamor for better design and construction practice in the Philippines. And at the time, there are no structural codes prevailing, and the seismic provisions, which are even are followed by most of the engineers, is basically 10% of the weight of the building. So in 1972, after that incident, we had now the first National Structural Code for Buildings, the first edition. It is actually based on the Uniform Code of 1970. It divided now the Philippines into 3 zones, Zone 1, Zone 2, and Zone 3. And then the base year now is computed to be ZKZW. But it doesn't have any requirements for ductility that actually include now the effect now from the experience now from 1971 San Fernando earthquake. And at the time, during the reign of a former Imelda Marcos, we hosted now the International Monetary Fund, which actually saw now the rise of these big projects in the Philippines initiated by the government, the Cultural Center of the Philippines, the Folk Art Theater, when we hosted the Miss Universe in 1976. And then we also hosted the International Monetary Fund, where we actually built this Philippine International Convention Center, and some of other centers, the heart center, kidney centers, all the centers that we built during those regime. The period shortly after the, Anyway, during the, in 1983, August 21, Ninoy Aquino coming back from Boston was assassinated in the tarmac. That actually leads now to the tremendous effect now on the economy, wherein the exchange rate now was actually down from $27 is to 27 pesos to $1. So there was now a rampant protest now that actually occurs now after the August 21, 1983 assassinations. As a result, no construction activities were carried out. There was a decrease in overall government spending. There was a restrictive monetary policies because detrimental, especially in the industrial sector. The majority of government programs are actually just focused on agricultural sector, and therefore construction is actually standstill. And at that time, the tallest building in the Philippines is 112.3 meters. The Pacific Star Nauru building, which has a 29-story and a 4-basement level. And then because of that EDSA people power revolutions, we were able to boot out now the former president. And then right after the EDSA revolutions, there's now a developer now that actually proposes now this 43-story residential condo along Ayala Avenue. And it actually became the tallest building at the time of 43-story. And then we're also now using now the NSCP 1987, which is based on 1985 code. Earthquake is equal to ZKZ, and then CSW. And then the first building in the Philippines to use 6,000 PSI concrete. And we're actually doing now a dual system for this building, central core plus a special moment resisting frame. And at the time also, the biggest shopping mall in Asia is about to be constructed at 330,000, the mega mall. It's a large span, a column grid about 32 meters. We use a post tension reinforced concrete beams. And then in 1990 again, we were actually hit now by this 7.7 Luzon earthquake. And that actually affected now most of the northern part of the Philippines. The Baguio is the summer capital, which actually saw now the collapse of the Baguio Terraces Hotel. And also a lot of liquefaction damages now in the Dagupan area. And where you could imagine now the epicenter is actually about 250 kilometers away from Baguio, but the effect is actually felt more on that area rather than the Metro Manila area. So at that time now, so we have now the National Structural Code for Building, the fourth editions. It's actually based now on the UBC 1988 code. There's now an inclusion of a zone map, zone 2 to 4. And then there's now introductions of R factor, where the base year now is computed to be ZIC divided by RW multiplied by the weight of the building. So, and then in 1992 to 97 now, so now the rise of the construction projects in Metro Manila. We have now the PBCom Tower at 259, 52-story office building designed by SOM. Then also the GT International Tower designed by KPF. And then the LKG also designed by KPF. And then the Ayala Tower 1 designed by SOM, San Francisco. And then until we were hit again by 1997 in Asian financial crisis, wherein the 26 pesos to dollar becomes actually 54 pesos per dollar. So again, there was now a standstill in the construction business, no investment. Projects were actually put on hold. And even those projects that were actually under construction, they were actually stopped. In the June 1997, the office vacancy rate for Makati were extremely low at 0.9%. But by September 1998, the Makati area then had a vacancy rate of about 6%. So the National Code of the Philippines now continue to develop. Provisions of the UBC 1997 are still being adopted. So we have now the NSCP 2001, 2010, and now lately now the 2015. But meanwhile, the international practice also advances at a rapid pace. We have now the seismic design is now based on the mapped spectral accelerations, based on the IBC from 2000, 2009, now 2018. Building codes are intended to establish the minimum requirements for providing safety for life and property from hazards. They are basically prescriptive in nature. Acceptable material for construction, they approve a structural and non-structural system. They required minimum level of strength and stiffness. They show you now how to details now, say, a column confining and joint reinforcement. And then there's a level of performance is implied without accessing the actual performance capability of the building. And the question is, if you're actually code compliance, are you actually achieving now the performance objective? So is code compliance enough? The development of seismic design criteria is a continuous process. It's starting in 1933, Long Beach earthquake, minimum level of lateral loads. 1971, San Fernando earthquake, ability to deform without failure, the ductility. And then the 1994 Northridge earthquake, damage can still occur, even if you're actually code compliant. As actually experienced during the recent earthquake in Mexico, wherein even though most of these buildings are actually code compliant, they still actually, buildings that were actually designed in accordance with the code still suffered a certain degree of damages. So now the code says that you have to provide now confining and joint reinforcement at a maximum spacing of 100 mm on center. This is actually to provide now certain extra strength now beyond yielding. And the question is, if I'm going to provide now a spacing of 125, I'm no longer code compliant. And what does it mean? Does it mean failure? Does it mean will the column will actually yield? And do I need to provide now this 100 mm joint reinforcement for all columns, for all floors, for the whole building? Performance is not guaranteed by the code conformance. Performance can actually be achieved even without conformance, because the code says that there is actually a certain exemption saying that these provisions are not intended to assure zero damage to structures nor maintain their functionality after a severe earthquake. Changes in the state of knowledge and development of new analytical tools should translate now to evolutions in structural design practice. And there is also an alternative system that is actually allowed by the code. The code says that the provisions of the code are not intended to prevent the use of any material, alternate design, or method of construction, nor specifically prescribed by this code, not specifically prescribed by this code, provided by alternate has been permitted and its use authorized by the building officials. And therefore, we're saying that since there's an alternative method of analysis, we can actually use now the more advanced state-of-the-art performance-based design approach, simply because the code now doesn't have any special provisions now for buildings that have outrigger, buildings that are actually diagrid, buildings with base isolation, and also buildings now with some dissipating dampers. So also we're actually allowed now to use nonlinear time history analysis as a part of our performance-based design approach. And this performance-based approach now explicitly evaluate now how the building is likely to perform under a given potential and it's likely to experience. So the process is select a performance objective, develop preliminary building design, assess performance, or the performance are actually meeting the objective. If not, then you have to assess now the performance until you actually achieve now your objectives before it is subjected now to peer review. So it actually allows you now, it actually provides a higher performance for critical structures than intended by the building code. It can actually be applied both for new and existing buildings. And the code says, and the references says that you have to check now the building performance now under this 2-level of earthquake, the SLE at 50-year return period, and also at the maximum considered earthquake at 2,500-year design period. So that for a frequent earthquake, the basic objective is operational. For occasional 72 years, basic objective is immediate occupancy. And for 475, it's life safety. And for MCE, it's a collapse prevention. And there are already existing references now in US that we use now in the conduct of performance-based, the TBI, the LA TBS DC ASC 41. And why PBD? Because we're trying to integrate now aesthetic, integrity, and economy. Aesthetics, the art that exists within the built environment. Integrity, the backbone of structural engineering, stability, strength, and stiffness. Economy, enhancing now the quality without sacrificing costs. Why PBD? Because buildings are getting taller. We have now the 75-story Stratford residences under construction. We just completed now the Trump Tower in Manila. And then also a 72-story Gramercy at 250 meters. Buildings are getting more complicated. This building is actually designed by Daniel Lipskin. It's actually very complicated, very asymmetrical, vertical irregularities, plan irregularities. You got now these sloping columns. You got now these mushrooming columns. And buildings are actually getting complex. We have now designing now 6 towers on a single podium without any expansion joint. And today, there are almost 100 buildings now in the Philippines that were actually designed now using a performance-based design approach. And those highlighted ones were actually equipped now with energy dissipating devices, just like buckling restraint braces, viscoelastic coupling dampers, as well as sluicing tank dampers. So This actually started now the performance-based design approach in the Philippines. At the time, they call it a displacement-based approach. We did this one now in the Philippines with MKA. This is 180 meters, 53-story, and we utilizes now the tank on the roof deck as sluicing dampers in order to resist now wind vibrations. And today, there are already more than there are so many 250 meters buildings that were actually constructed: the Shangri-La, the Fort, the Trump Tower, the Gramercy, the Proscenium, the Spire, and then this is now about a 32-story building along Ayala Avenue, designed by SOM New York. It's actually just a small building, but very interesting because they slice it up from the top, creating now a view now along Ayala Avenue. And the columns are actually sloping now when they actually reach now the ground floor, creating now a 5-story volume lobby, which is actually very dramatic and very interesting. It will open now next year. And then this is now the first building that we designed using now buckling restraint braces. And after this building, we did about another 6 buildings now using BRB. So lately, we started using now the viscoelastic dampers for this Park Central terraces. There are 2 towers. One is about 70-story. The other one is about more than 50-story. These are now under construction, and to date, they are the most expensive condominium in the Philippines, costing about 400,000 per square meter. So in this building, we started first testing the system using BRB, and then we tried to test it using BCD, and we were able to gain now additional damping that actually reduces now the base shear as well as reduces now the building cost. So looking ahead now, the Philippines has the same earthquake risk as California, Japan, New Zealand, Haiti, and etc. However, we're saying that traditionally, our practice now in the Philippines is not really at par with theirs. And so we believe that we should not be bounded by the limitations of the code. We should actually take advantage of the powerful software and hardware that are available in the market in doing alternative approach in order to ensure now better performing buildings against earthquake. We believe that code compliance is not enough, and we believe innovative approach is a must. Thank you so much.